Good afternoon, everyone. Today's title of my presentation is Relationship between light reflection from the eye and serum vitamin A level in beef cattle. This is the outline of my presentation. First, I introduce about my research, such as my research's motivation, such as beef quality, vitamin A level measurement, and objectives. And next, I will talk about the method of my research, about the material devices and image processing. And then I will tell you the result and discussion and conclusion. Okay, let me start from the introduction. Look at this picture. This picture shows the high-quality beef with high marbling score with intermuscular fat. To make better beef, breeders have to control vitamin A level at lower level. This graph shows the desired time series of serum vitamin A level. So breeders have to control vitamin A like that. However, under 30 IU, under 30 IU per deciliter, cattle get a disease that is called vitamin A deficiency. So to make high quality beef safely, management of vitamin A is essential. Here's the current method of the to measure the vitamin A level. Currently, vitamin A is measured by the blood assay. However, blood assay have many disadvantages such as high cost, time consuming, and stressful. So simple and easy measurement of the vitamin A level is needed. So then our group focused on the image processing of cattle's eye. Our group's research is about the cattle's color, pupil reflex, and light reflection of eye. And for me, I especially focused on the light reflection. Then I will tell you why I researched about the relationship between light reflection and vitamin A level. When serum vitamin A level goes down, cattle's surface becomes dry and rough, according to previous study. So then I made a hypothesis that when the surface becomes dry and rough, this diffused reflection on the surface become increase. I made a hypothesis like this. So I think the light reflection is changed by the status of the surface. And here is the result in 2011, last year. This graph shows the time series intensity of reflection and vitamin A level about all cattle in every month. This graph, as you can see, vitamin A level goes down. When vitamin A level goes down, intensity of the reflection becomes higher, and then vitamin A level goes up, then intensity dropped. So this graph shows the negative correlation of the between intensity of the reflection and vitamin A level as shown. And this graph also shows the reversible change. This is the objective of my study. The final goal of my research is to establish the measurement of cattle's serum vitamin A level by image processing for high quality beef. And the objective of my study is to research the relationship between the light reflection and the serum vitamin A level. To achieve this objective, I have to confirm the repeatability of the result in 2011, last year's result. Here is the material of this year. 42.7 cattle are used in this experiment. And the experimental period is from February 2011. At that time, cattle's age is about 10 months old. every month we get images and vitamin A level data. Here is the device to get the image. We used 2CCD camera to get visible image and NIR image at the same time. And in the experimental period, we changed the light intensity from 1,200 to 1,700. And here is the image acquisition, how to get the image. First, we cover the black cloth over the cattle's head to dilate pupil. And then put NIR LEDs on inside the black cloth to detect the pupil position by NIR vision, like this. Then put white LEDs on and get images. Here is the image processing, how to process and get the reflection component of the eye. Here is original color image. Firstly, the color image is separated into grayscale of RGB to detect halogen part. Halogen part is the specular reflection of LED ring, that white part. And then I made the rectangle around the halogen area and determined the ROI inside the rectangle. Then I removed the halogen area because halogen area is saturated, so it affects the result like a noise, so I have to remove. Then I calculated the mean value of RGB in the ROI and calculate the HSI from the mean value of RGB. This is a result of 2012. As you can see, you can separate here, like, because we changed the light intensity like this, so you can distinguish the result because intensity, if when intensity of the light source increase, of course intensity of the reflection increase, like that. So this is result is not correct. So I removed the result from February to April. And here is the extraction from May to August. There is a quite large deviation. However, negative correlation is shown. So this result shows the same tendency with last year, 2011. Here is a conclusion. Negative correlation between the intensity of reflection and vitamin A level was shown in 2011. And the same tendency is probably showing in 2012. So that means it may be possible to confirm the repeatability. However, the period to monitor the vitamin A level and research is too short, maybe. So we have to continue this experiment and monitor longer and longer. And it is important to establish the prediction system with time series individual data to remove the effect of individual difference. Now I'm making this time series of individual data. That's all. Thank you for your attention. Question? in this year I use 47 cattle. Yeah.
47 cattle. Then you told that the repeatability was confirmed. But that is which range, which age? What's the age of the cattle? And another time you already got what kind of cattle? So such a information is somewhere.
This is a material of last year.
Last year. This is last year.
Yes. And we measured in this period from 12 months old to 28
This is
months.
last year.
Yes. This is last year. And
This year. Not easy to understand.
From February to in 2012, we start to use new cattle.
Why don't you, overlay the last year cattle, this year cattle, then this period was compare something like that. That's easy to understand.
And
someone.
You show the tendency of negative correlation
はい。
from last year.
ですか。あ、はいです。
But your final goal is to estimate the vitamin A level
Yes.
quantitatively. So how you estimate the accurate vitamin A level from your result data?
Yes, maybe component of light reflection is not enough to measure, predict the vitamin A level. So finally, maybe we will do this multivariable analysis. Not only we, but also Hansen study about the pupil color and pupil reflex and with the vitamin A level. So now we accumulate data, much data, and then we use this multivariable analysis to predict vitamin A level. Then maybe the error of individual also, and the how to say, high correlation may be shown.
How many data is needed?
How many data? Maybe more data.
It is not enough to do a multivariable analysis at present.
Now,
Enough.
1 year is not enough, I think. So, we accumulate data 2 years, then we use this analysis. That is maybe better way.
So in that data, the light intensity is an important parameter.
Yes. Yes.
Good discussion. Any other such that?
Yeah. Usually when we want to know y variable with x variable, we have a equation that connect two variables, like y equal to x plus something.
Yes.
I don't see that equation in your presentation.
Presentation. Sorry, what kind of formula?
Yeah. You want to know the vitamin A level
Yes.
in cattle.
Yes.
You want to what to say, to guess vitamin A level
Yes.
from the image.
Yes.
I expect you have a graph with connect that, for example, x direction is intensity and y direction maybe vitamin A level, like that. So we have you mentioned also about negative correlation. That should be something, some equation with appear that if there is correlation between the two.
Yes. So maybe later I will calculate the formula. But now still I research about the relationship because that relation is not so clear still. So here is now is not prediction.
You mentioned already when the vitamin A level high, the intensity is low.
Yeah.
That is you mentioned already.
Yeah.
You know that fact. But how close these connect each other?
Connect.
Yeah. How close
each other.
the vitamin A? How accurate we can use the intensity to predict the vitamin A level? I think it's better to make scatter graphs and you can get the trend line and the equation.
Yes.
You have the data.
Yes. So I have image data and I have process program. So then I have to make that scatter graph.
Yeah.
And yes.
So you already had some coefficient of the relation.
Last year.
Not this year.
Not this year because this year only four months is data is reliable.
So no R square.
Yes.
This moment.
Can you please show me slide number 3? Here you are on the graph there of vitamin A versus age. You're showing the change in vitamin A and that deficiency occurs around 30.
Yes.
From a management of the cattle, looking at management of the cattle, when do they have to supply vitamin A to ensure that it doesn't go below?
Usually in this period, so reducing vitamin A period, breeder don't give the vitamin A by food. Don't give. And then vitamin A reaches to dangerous range. Then breeder give vitamin A by some medicine, vitamin A medicine. Then control and control.
So the critical period to measure vitamin A is between 18 and 22 months old.
Yes.
So can you then now go to your graph of showing vitamin A correlation with intensity? Can you go to that one, number? Okay.
This?
This one, yes. Okay. On this graph here you have months, but where is 20 months old?
I think around here.
Okay, so it's very important that if it is in October and November, then there is a very big difference. Whereas in February, or January, there's not so much difference. But that may not be important for your studies if your critical period is at the 20-month-year-old period.
Yes.
So rather than looking at time series, trying to get an absolute correlation, for your applied subject, the critical period, it would be better to show focus on that area rather than a time series for the whole period.
Okay, thank you.
One small question. Slide number 2.
Number 2. Oh, okay.
Number 3.
Number 3.
Yeah. You show us the good beef with marbling mark.
Yes.
I don't know how bad, not good beef looks like.
We usually eat. Every day eat.
I think he show both. Yeah, to educate people also. This is a good beef.
So I have to show normal beef and
Yeah, good one,
Yeah.
normal one, or bad one. It's maybe will make sense to audience that's not familiar with cattle beef like this.
Okay.
I heard because Kobe beef is very famous. Because I heard different things. Good beef we will have very small fat separate over the meat. This is big fat. Yeah. Outside the muscle.
That was a fat in fine.
Yeah, fine one is good.
Yes, in mask.
Yeah. The thick fat is not good. So maybe better to show some or other type.
Yes.
Anything else? Okay, thank you very much for the discussion.